Hey, g'day, it's Prezzo. Welcome back to the workshop today. Now today is the day we're running the Titan engine for the very first time. Now I promise you I haven't run it up to this point. Now ordinarily I would rehearse all of this off camera. I would check that the engine started, and then I would turn the camera on and pretend to be doing it for the very first time. But in this case I haven't. Now don't act so surprised, everyone does it, trust me. But in this case I haven't. Now I want my reaction to be truly authentic. So if it starts, that's brilliant. If it runs, that's even better. If it's a dismal failure, well, you get to see my disappointment. Now you'll also notice I'm wearing my Lockheed t-shirt from Skunk Works. And if you're a bit of an aircraft nerd like me, you'll know about Kelly Johnson. He was the engineer and designer behind the famous SR-71 Blackbird aircraft. Now, if you like reading about engineering and aviation, there's an excellent book called Skunk Works. Here it is on the screen now. And I'll put the ISBN number in the description below if you'd like to read that. But it was hands down the best book about aviation that I've ever read. Now, if you're the impatient type and you don't want to hang around and hear me talk about the process leading up to this point, you can check the time code in the description below as well, and you can skip forward to the part where we actually start the engine, or I hope we're going to start the engine. So if that's you, you can leave via the side door. Ah, look at them, so many. Oh, brilliant, okay. And last one out, shut the door, will you? And don't slam it. Okay, for the 5 of you left behind, let's talk about the process leading up to this point. First job I need to do to get the engine ready to run was to make 3 gaskets for the engine. Now, one goes between the cylinder head and the cylinder liner, between the cylinder liner and the top of the crankcase, and between the bulkhead mount and the back of the crankcase. Now I was able to draw all of those shapes in my CAD program, and then I used my CO2 laser engraver to cut out the parts. Now I used a type of thick-ish paper. It's the type of paper they use to make mailers and mailing envelopes. So it's sort of halfway between a cardboard and a paper. Now it's thick enough to be resilient, so you can squish it down when you apply torque to the screws and the fittings and so on, but not so thick that it artificially increases the distance between those mating parts, and that could affect the compression ratio of the engine. So I cut out way more than I needed. I need a set of gaskets for this first run, and I'll need another set when I finally strip the engine down and do all the finishing and put it all back together again. But yes, laser cutter engraver does an excellent job for that process. Well, the next part that I had to actually finish, and I unfortunately forgot to show this in previous episodes, but that was the gudgeon pin, or the wrist pin, whatever you like to call it. It's basically the pivot between the piston and the top of the connecting rod. Now, in the notes it actually said to make this out of a piece of 1/4 inch silver steel, which is like a hardenable steel. Now, I suspect the material was chosen because it's precision ground and it's quite tough. But it's a solid piece of steel, and in order to lighten it, and for another reason, it had to be drilled through, and then the ends of that drilled hole had to be opened up with a 100-degree countersink. Now, in order to fill up the ends of that piece of steel rod, it was fitted with a pair of aluminium aircraft rivets, a countersunk head type rivet, and they could be punched into the open holes in the end of the gudgeon pin. And then from there I took that part over to the lathe, and the excess material was cut off. I had to make a split type collet in order to hold that part because both ends were bigger than the center, and I machined away all of the excess material, leaving the heads of the rivets slightly long. Now the ends of the exposed head of the rivet were profiled with a file just to make them sort of spherical in shape, and that brings the length of that gudgeon pin up to be the same as the diameter of the piston. Now what that does is it makes sure that as the piston completes its stroke inside the liner, the gudgeon pin won't score the liner of the cylinder. So it's basically rubbing on that aluminium cap against the liner. There are no circlips to hold that gudgeon pin in place, so it basically floats backwards and forwards as the engine is running. But I believe that that's basically the measure that we use to make sure we don't damage the liner. Final thing I had to do before I could reassemble this engine was to make sure that all of the parts were scrupulously clean. Now, as I finished each of these parts, they went into a tray on the bench, and they sat there over a number of months, and it's almost inevitable they're going to attract dust and debris and grime and so on. And also the parts that I had lapped with the diamond lapping compound, I wanted to be sure that I'd gotten rid of any trace of that material that's left on those parts. So what I did was I put each of the parts into my ultrasonic cleaner. Now I used a product called Simple Green. Now, don't worry that it's orange, it's actually quite a good product, but it's a citrus-based cleaner. And in order to make sure I didn't waste too much of it, I actually just put the cleaner into a plastic bag with the part, and then put the bag into the ultrasonic cleaner. Now for some of these smaller parts like these, I just put them into a plastic cup and rested that in the ultrasonic cleaner. Now as the cleaner was doing its job, you could see that some of the parts, there was a lot of murky material left in the bag after the part had been finished its cycle, and that just is evidence that there is a lot of debris and muck on these parts. Now once the parts come out of the ultrasonic cleaner, they were blown dry with compressed air, and then I coated each of the parts with WD-40, put them into a Ziploc bag ready for assembly. Now I'm happy to say the engine went together without having to rework any of the parts. It just bolted all back together as I hoped. I put all the gaskets in and I torqued down all of the screws, made sure everything's tight, and yes, I have flicked it over and it sort of sounds right. So I'm hoping that's a good sign. Now I'm going to run the glow plug from my little power supply here. I don't have a battery that can supply the 1.5 volts that the glow plug needs, but I've checked with the power supply and the glow plug glows quite well, which is what we want. So I've got an earth wire on the back of the engine on one of the mounting bolts, and we're just going to run the hot wire to the top of the glow plug like that, and that's going to get everything going. So what we need to do now is get set up, and I'll reposition the camera, and I'm also going to start the engine with this. Now I don't fancy chopping up my fingers with an unpredictable and untested engine, so I'm going to use this in my cordless drill. That rubber bush there has just been machined out on the lathe, and that'll contact the spinner and provide enough friction to drive the engine. So yeah, I will try and flick start it when I know that it runs and also when I know how predictable it is. But yeah, these things can backfire and chop your knuckles up very quickly. Okay, let's stop talking, let's get busy. Ooh. Come on. Whoa. That's not supposed to happen. That's what happens when it backfires. So it wants to run. It's flooded. I just had to stop there. I got a phone call from my sister. They've been flooded in for the last 3 or 4 days. They also had no phone coverage. I don't know if you know, but there's been pretty extensive floods in southeast Queensland and northern New South Wales. And although we're okay here, my sister lives in an area that cut off very quickly after the rain started. Anyway, they're okay. But I just took the opportunity to have a break. I've gone to have some lunch, and I'm thinking over what's happened here. Certainly not what I was hoping for. I did actually try a few flick starts on this, and I can get sort of like 3 or 4 pops in a row, which makes me think it wants to run. And I don't know whether it's a fuel issue. I don't know whether it's just not got enough compression. I know the glow plug is working, and I know that if I cover the Venturi and give it a couple of flicks, it's sucking fuel through from the tank. So it's at one point, in fact, I actually flooded it. You might have seen that. So I don't think it's fuel, certainly not the glow plug, so it's got to be some sort of compression issue, or I just don't know what the needle valve position needs to be. So what I'll do is I'll turn the camera off. It's not what I wanted. I was hoping I'd get this to run on camera without having to stop, but I need to focus on what I'm doing here. So I'm going to turn the camera off now. I'm going to mess around with it a bit. If I get it running, I'll bring you back. Well, here we are, what, 3 hours later, and I've got the engine to run. Now, it turns out it wasn't the engine, it was the glow plug. Now, this is the glow plug that I bought, and it was the one that was recommended in the notes. It was a what they call a long reach plug, and when I was running this on the bench, I noticed that it didn't really glow all that well. And when I was connecting to my power supply, it was showing 0.7 of a volt, even though I'd set the power supply to 1.5 volts. So what I did was I went rummaging through an old box that I had with a nitro car in it, one of those little radio controlled cars. It was one I bought for my son many years ago. Took the glow plug out of that motor, put it in here, and the engine started almost immediately. Now, it wouldn't run for any length of time, but I played around with the fuel setting, and I think I've got it to a point where it's running consistently. And we're going to start it up in a minute. And I also upgraded my starting system. So this Milwaukee drill, a corded drill, runs closer to the speed of the motor. What I was noticing when I was using the cordless drill is it would fire, and then the inertia of the drill would actually stop the motor from going any further. So that, coupled with the faulty glow plug, meant that I was in for a frustrating time no matter what happened. So let me get set up again. Everything is messy. I've just about destroyed the spinner on this because it's unscrewed itself about 4 times and hit the floor and spun across the workshop. So that's going to be either remade or refinished, but that's okay. I'm happy to do that. I'm just glad the engine is running. So let's see if we can recreate what we were doing before, and yeah, it's happy days. Alright, it runs. Not well. You might have noticed when I took the plug lead off, it sort of started to 4-stroke or not run well. So I don't know what that's all about. I'll ask an expert and they'll be able to tell me. But at this point, that's good enough for me. Okay guys, there it is. Now, it's not the best engine in the world, I know that. I'm just happy it runs, and I would have kept running if I hadn't cut off the fuel supply there. So I'm happy with that. I did notice at the back of the engine where the crankcase butts up against the bulkhead mount that there was a little bit of bubbling happening there, so there's a bit of a leak. So maybe my gaskets aren't as good as I thought they were, but it seems to be okay. So all of that angst and all that problem was about the glow plug. So you would have noticed also that when I took the plug lead off, it started to miss. It was only sort of running every second stroke, I think. And I don't know what that's all about. Maybe some expert out there can tell me. But at this point, if it runs, I'm happy. And that's all I ever wanted to achieve with this. Now, I'm sure that somebody who's an expert would be able to diagnose some problems with this and improve its performance. But it is starting okay. I suppose I should be a man and actually try and flick start it. But what I've noticed is that it'll actually spin over, and then when it starts to fire, you can see the fuel being sucked up this tubing. So until it gets rid of the air in the tube and gets solid fuel supply to the spray bar, it won't run continuously, which could make it difficult to hand start it. But I was flick starting it before, and I could get a couple of turns out of it before it would just die, which obviously was a glow plug problem. So I'm going to cut this off here now. I'm going to quit while I'm ahead. I thank you for watching today. I'm glad I didn't disappoint anybody. I'm sure I was certainly disappointed. I was looking a bit glum when I went up to have lunch, and my wife said, "What's wrong, dear?" I mean, what can you say? My engine won't run. Yeah, like you're going to get sympathy for that. But there we go, it's running, and what I'll do now is I'm going to dismantle the engine, clean it up, do all the finishing processes, get it back together again, make it look beautiful, and then it's off to the USA. So yeah, it's better than I thought. I sort of had high hopes, and then I was, disappointed. But there you go, you got to persist, and you got to do the diagnosis, and you got to work through the issues, and well, that's what it was. Anyway, Prezzo, thanks for watching. Check the next episode, which we're going to do all of the finishing process on the engine. That's going to be interesting just in its own right. So yeah, thanks for watching today. See you on the next episode. Prezzo, cheers. This is a juvenile Australian native scrub turkey, sometimes called a brush turkey or a bush turkey. And these are a solitary bird, truly amazing. They're largely flightless, although they can fly up into branches to roost in the evening. And this one is, well, it's been hanging around the house here for about the last 2 or 3 weeks. And we often find it down near the chook pen or the chicken pen. And it seems to be hanging out with the chickens. I'm sure it thinks it's one of them. But this one, I don't know whether it's a male or a female, but the thing about these birds is that they lay eggs in these massive mounds that the male or the dominant male bush turkey will scratch up. And these mounds can be up to 1 metre tall. And they wait for this mound of vegetation to start to compost. And when the temperature is just right, the female comes along and lays her eggs. And the male will actually check the temperature of this mound by putting its beak in like a thermometer, and then he'll either add vegetation to the mound or scratch it away to keep the temperature correct to incubate the eggs. And when the eggs are almost ready to hatch, the male abandons the mound and the baby birds hatch out and claw their way out from underneath this mound. And the very first thing they do is they run. They're born fully fledged, and as soon as their feathers dry out, they can run fast enough to get away from most predators. So that's their main defense. And the other thing you'll notice is that the head of this bird is basically just red skin, and the males, when they're ready to mate, the heads become much brighter, and they have a wattle that hangs down around their neck, which is bright yellow. And when my daughter and her little friend were small and they saw these birds, they would call them busted balloon birds because that's exactly what this wattle looked like. So yeah, this one's just settling down now. totally unworried about the fact that I'm standing just a couple of meters away. Like I say, they can run very, very quickly if they're threatened. So there you go, native Australian scrub turkey or brush turkey.